Hello, everyone, and welcome back to Editing Humanity, the podcast where we dive into the ethics, science, and stories behind gene editing. I'm your host, Shreya, and today we're zooming in on how CRISPR is being used in microbiology research in the current times. In this episode, we will be talking to a graduate student who works in Dr. Bridget Barker's lab on the NAU campus, and this is a lab that works with CRISPR currently. Her own research involves expressing antigens in E. coli with the goal of developing a vaccine for valley fever, a serious fungal infection that's especially common in the American Southwest. It's an exciting look at how gene editing can go beyond theory and actually help solve real world health challenges, and even more exciting to talk to someone that is in the forefront of such research. We will get into what their day to day research looks like, how CRISPR fits into the bigger picture, and the ethical questions that come up when we start engineering microbes for human benefits. Stick around, because this one gets into the microscopic details of one of the biggest tools that is shaping the future of science. So, Nicole, we're so glad that you're here. Welcome to Editing Humanity. Would you be able to give our audience a little intro about yourself, like what you like and what you do?
Yeah, thanks for having me on this podcast, Ray. I'm very excited to talk about everything. So I have been working in this lab for around 2-ish years, since I was in my third year of undergrad. During that time, I was preparing samples for whole genome sequencing so that we can better understand the phylogeny of this pathogen and what areas are being the most affected. And then after I graduated and got my bachelor's, I remained a research technician, and this is where I really started doing CRISPR designs. And now I'm as a master's student, and I am working on my protein expression work.
That's really cool. We're really excited to hear what you have to say about this topic, and it's really fun to meet somebody that is actually doing research in this topic. So let's get into the questions now, if you're down for that.
Yeah, absolutely.
Okay, so the first question I have for you is, what drew your lab to working with CRISPR technology in your research?
I honestly just wanted to have the experience of being able to work with CRISPR. I was very new to this topic at the time. I didn't really know the bigger aspects of it. I just knew it was gene editing, and I knew that that was going to play a really large role in the future, especially as technology continues to make advancements. So it's super innovative research, and when I was presented this opportunity to do these designs for guide RNAs, which is what directs the Cas9 enzyme to these specific sequences for editing, and I was also designing G blocks, which were templates for constructing or modifying the genes. It's telling it where to make the cuts. I immediately wanted to do it and learn more. And it was a fun project.
Yeah, that sounds like a lot of fun. I completely agree. With this technology, when I read about it, I was also very excited. And me personally, I haven't had the chance to work on it or with it, but it sounds like you're having so much fun with designing all this stuff, and I cannot wait to talk to you more about this.
Yeah.
So moving on to my next question for you. I wanted to ask you, how is CRISPR being used in your lab, and what are some of its current applications?
Yeah, so this project is ongoing and is not really published yet, so I won't go too deep into it. But in this lab where we're studying this fungal pathogen, valley fever, coccidioides, the CRISPR in the long run is going to help us understand virulence or disease severity of this fungus, its pathogenicity, so how it's able to grow and spread, and what genes are responsible for what functions. So using the CRISPR is going to help us better understand everything in the long run.
That's awesome. Yeah. So just kind of a follow-up question off of that. So how exactly, if you know, like how exactly does CRISPR help you like know these pathogens better? Are you using like CRISPR to cut out gene sequences and study them or something else like that?
Yeah, so we have genes of interest that we're looking into that we believe could play a larger role. And we just cut those out and replace them with some alternate sequence, like an antibiotic resistance marker. And we just then grow it and see how that affects, just like how it grows.
Awesome. That's super cool. Very exciting. Okay, so my next question here for you is what do you see as the most promising future use of CRISPR in microbiology or pharmaceuticals?
So this was that's a great question. But I feel like if CRISPR is used correctly and ethically, which I'm excited to get into later, I believe that it could help fight infectious diseases and develop new drugs and therapies for genetic diseases. But I think that CRISPR can definitely do more in the future regarding these disabilities and diseases. But that is a very controversial topic. And I don't necessarily endorse using it directly on human beings like that, because we don't want to start some sort of eugenics problem.
For sure. Yeah.
But I know that the technology in the future is capable of reaching that point.
Yeah, I completely agree with you. So kind of going off of that, how do you ensure like accuracy and like minimize off-target effects when using CRISPR in your experiments or in your lab?
So the main thing that I would want to be looking for when I was designing the CRISPR tools was to avoid issues like this, would be to avoid using repeated sequences. So sometimes when we're looking for a certain guide RNA, there would be like the same 20 base pair sequence that repeats anywhere from like 2 to 11 or more times. And you don't want something like that because then it could guide to the wrong sequence in the wrong area, and that could either just like simply not work, or it could create more like off-target effects. So we want to make sure we're making the cuts in the right places and that the sequences that we're using are unique to this gene.
Awesome. That's perfect. That sounds like a lot of work, but seems like you have got it under cover. So moving on to more like to the public understanding side of CRISPR, I'm sure you must have presented at like conferences and like presented your research in general. So what do you think is the public understanding of CRISPR and if it matches to the speed of its development?
I absolutely do not think the public understanding of CRISPR matches what's actually going on in the scientific community. So with the media and super clickbaity type titles, people can jump to conclusions very quickly. And we are in the prime age of misinformation with AI-generated concepts and just like people wanting to have other users of YouTube or the other news click to any title that just sounds remotely interesting. So we just need to make sure that the science needs to be communicated honestly and properly to avoid it being politicized so much, and so that the public can actually trust the scientific community that we're creating to help them. And a lot of people, I think, out there are doing way more than we actually are. So it's because CRISPR is kind of a creepy subject if you really think about it go deep down and think about it. It feels straight out of a sci-fi movie, and for movies you should watch Gattaca. It's a great movie. It's about just about gene editing and like engineering babies and whatnot. So actually it's straight out of a sci-fi movie.
For sure.
So this is also just a subject that people, especially people of different religious beliefs, might be uncomfortable with. And that's okay. Like, it's all right to feel, a little scared or overwhelmed by the technology. Because, like, the public thinks that we're already designing babies for people, like it's Build-A-Bear. And really, we're still most of us, I think, are still on a microbial aspect. But there was that thing that came out about the dire wolf.
Oh, yeah.
How they
Yeah.
brought it out, and I just don't think that was a good thing.
Yeah,
Like,
I completely agree with you. I think there's a lot of stigma around the concept of CRISPR, and I think the stigma comes from the fact that public isn't educated on the topic very well. Like as you mentioned, like everybody says that that this technology is going to be used to design babies for people, which is a possibility, but that's not where the CRISPR technology is going. From what
Yeah.
it sounds like from your research, it's going towards more of a vaccine development or more like microscopic scale. And I think it's kind of funny to think about that people are freaking out about this technology, even though we're nowhere close to designing babies for
Yes.
other people.
yeah.
Great answer. Thank you for that. Moving on, I wanted to ask you, like, what are some ethical safeguards that your lab uses or have in place for CRISPR-related work?
So for this, I'm not too sure. I mean, I was just doing the designs. I'm not in the lab doing the actual CRISPR experiments. But I think that's just because we're working with a microorganism rather than entire animals. So we
Yeah.
might have a little less regulation, but every protocol that we do has to be approved by like some sort of board or like,
Yeah.
so it's not like we're just going in there willy-nilly and doing whatever we want.
Okay, awesome. That's perfect. Okay, so moving on to my next question, how do you balance scientific innovation with the ethical responsibility of designing CRISPR experiments?
So, I mean, I think this is also just because I'm dealing with a microorganism, but it was easy at times when I would be doing the designs to feel like I was playing a game and not really thinking of the actual science and what was going on, and that we were actually cutting sequences out of, cutting gene sequences out of this fungus. I think it's still so mind-boggling that I was even doing that. It's kind of like the show Severance. Have you watched Severance?
Oh, yeah, I love Severance.
When they're
Oh
doing
my
the
God.
macro data refinement and
Yeah.
they're like playing with the numbers and stuff, I was like, okay, that's a cool game, and they're not even working. So occasionally I think it would have been nice if I sat down and just realized what I was doing. But I don't think I was doing anything that could be considered unethical, because really we're just trying to help fight this disease and make sure that, people aren't getting sick. And, I was just really thinking, I'm contributing to science in a cool way. I hope this design works.
Yeah, for sure. From what it sounds like, that it's really easy to forget when you're working with such tiny organisms that there's still an ethical responsibility involved.
Yeah.
But I'm glad to hear that you still realize that it is a big responsibility and that you acted on it.
Yeah.
But that's such a mind-boggling thing to like think about, that when
Yeah.
you're like doing science, it's so easy to often like forget that you're working with actual microorganisms, or you're actually altering like this microorganisms
Yeah.
DNA or genes.
Yeah, even outside of CRISPR, it's just like, oh, like I'm just playing around with this E. coli, even
Yeah.
though like, we're actually doing groundbreaking science and we need to be, thinking about it critically and safely.
Okay, awesome. Yeah. Moving on to my next question here for you. Where do you personally draw the line between therapeutic gene editing and gene enhancement?
I think that all really depends on the purpose of the work. So I feel like if you're doing minor work like what I was doing for an overall, good cause, I'd say you're using the technology properly and correctly, I say in quotes, because this is all dependent on what kind of person is going to be giving their opinion. However, I feel like if you're trying to modify animals or humans by changing key parts of them, you're getting into some really murky territory. But from just like the nerd standpoint, I'm like, whoa, that's really cool. Even as clickbaity as the dire wolf thing was, where I
Yeah.
literally got a notification and it said, we brought the dire wolf back. It's like, I had to be like, no, you did not. But, cool technology, but no, you did not. But changing, I think, key aspects of our biology for fun or aesthetics or, just trying to eradicate certain things that make people who they are is no bueno.
Agreed. Yeah, that seems to be the general consensus opinion of it.
Yeah.
But kind of playing a little bit of devil's advocate, I would like to say some people, like especially with like disabilities,
Yeah.
there's a lot of conversation about CRISPR surrounding disabilities. They say eradicating disabilities using the CRISPR technology is something good because it's like getting rid of something that is causing pain to these people.
Right.
But there's another side of like the disability movement that claims that this whole ideology of eradicating diseases using genetic editing
Yeah.
or gene editing is considered ableist. Do you
Right.
have what are your thoughts on that?
So it's like, I was just thinking, like, if CRISPR technology is able to, help eliminate susceptibility to, like, sickle cell anemia, when you're actually having that and you're just, like, constantly you're not 100% or you're not just completely healthy, then, I would have to think that that's a good thing. But meanwhile, if you are saying, like, CRISPR technology can help us, stop, like, deaf people or people who are blind. There's a whole deaf
Yeah.
community. One of my best friends works within the deaf community and is and some of them don't want to be hearing people. So then it's just like it brings in a whole other question of like, okay, like, should we even touch this territory?
Yeah, for sure. Sorry, we went a little off topic.
No,
on
you're
that.
all right.
Okay, so moving on. The next question I have here for you is there ever a time where you felt uncomfortable with the implications of your own research?
Not my own research. My work was really cool because it's going towards a good cause and innovative research for an infectious disease. So the CRISPR I was doing was quite light, I would say. It wasn't anything because we were working with a microorganism. I mean, it's still great, groundbreaking material. But I didn't have an ethical issue or a moment where I felt uncomfortable because of what I was doing. I was just thinking that this was for a good cause.
That's awesome. Because it feels like as like people outside the scientific community, sometimes they kind of force the scientific community to think about, or like they want us to kind of feel like uncomfortable with our own research.
Right.
It's probably, do you think the reason behind that is just stigma around research and the fact that the public is not educated on these
Right.
topics?
I think that the scientific community needs to earn the trust back from the public. I feel like we should be open about the work that we're doing, but also like we can't share information until our work is published, and that takes years. So then most of the time the public is like, okay, what are they doing in those labs then? If we're not able to be consistently communicative with them. So that creates some sort of mistrust. So I definitely feel like we need to work towards bringing those two communities together so that especially like the public can see us as like equals and not that we're just like too smart for them or whatever and they're like not or they're stupid or whatever. I think it's really important that we merge those two things together. And even like this is a little off, but some high schools are actually doing CRISPR,
Oh.
in their science classes.
That's super cool.
Yeah.
I did not know that's happening right now.
Yeah, and I mean, we even did it in one of our, I mean, I wasn't in high school at this time, but I was taking an industrial micro class, and we were doing CRISPR in that class, just like on the benchtop. So CRISPR isn't even most of the time that scary of a thing. And what we were just doing was knocking a gene out of some bacteria, I can't remember, and we were inserting like this P-glow strain and then plating it, and then if it fluoresced in the dark, then it transformed, then the CRISPR worked. But it's really like the public, I think, needs to kind of gain our trust back and be like, hey, like we're not really doing anything bad 99% of the time.
Yeah.
So yeah.
Awesome. Yeah, I completely agree with that. I think there's definitely a lot of like, especially with like news outlets and stuff like printing dramatic headlines about CRISPR and about research has led to a lot of things. Because I feel like with the scientific community, it's harder to like take out time for this from the scientific community to like go and like explain your research to all these people. Like you can attend conferences, you can give speeches, you can publish your research, but at the end of the day it really comes down to like how much the public is interacting with what you're putting out. And do you think there's any like better ways that we're moving towards to like bridge the gap, or
Yeah.
like anything that we as a scientific community are currently doing?
I think that you mentioned attending conferences, and scientists definitely do that, but those are usually like scientists with scientists. So if we had a public, way where just the general population can interact with scientists and learn about our work, and we can teach it to them in like a more like way, like
Hands-on approach,
yeah, or even use like layman's terms. Don't
Uh-huh.
even need to be too technical with anything
Yeah.
because they're not scientists. Also, I feel like there should be more easily readable scientific literature. Even I still have issues reading papers and interpreting what they mean. And also getting rid of those paywalls. I think my strong opinion is that I think all science should be accessible, and we should not have to have a paywall. And even just like community engagements, like in Flagstaff we have Science on Tap, we have the Community of Science. So this town is doing a great job with scientific communication.
So like other towns should take a note.
Yeah, take notes.
I completely agree with your point of like making science free, but kind of going off of that, I just wanted to kind of bring up a question that came to my mind.
Yeah.
You mentioned like making the paywalls go away, but kind of playing like the devil's advocate. If we do that, how are these like publishing companies gonna make
Yeah.
their money back?
That's-
And like, is it ethical of them to like charge? And like,
Yeah.
what is an ethical amount of money to access this information, and who should be paying like
Right.
for accessing this
To be
information?
honest, I haven't really thought of that. I think I'm just still salty from great papers are behind paywalls.
Oh my God,
And
yeah.
I'm just like, oh gosh, dang it. Like, I really wanted to read that. Get rid of the paywalls. But not thinking about the implications behind why there's paywalls and why, like, some of these journals, need to be making their money, and that some of this money can go back towards the scientists to continue doing their work. So it's all a business, but unless, there was some, like, how PBS is publicly funded,
Yeah.
if there was something like that where the public can help contribute, and then the scientists can put their information on there for free, and anybody can access it, maybe to find a way to just get around all of that.
Yeah, for sure. Okay, let's move on to my next question that I have here for you. So I wanted to ask you, do you think there should be like international regulations for CRISPR, or is a lab level oversight kind of enough in your like microbiome setting?
I think that there should be some sort of system to check and hold scientists accountable, like mainly, the very few that could have this technology go in the wrong hands. But very small population. I just want to, clarify on that. I'm not saying all scientists are mad scientists, but, there could be one in the entire world.
For sure.
So I think there should be some sort of checking system to make sure that this technology isn't getting put in the wrong hands, to be doing the wrong things, like genetically engineering a human being. That's illegal. But doing it, in secret is also not good. So I'm not really sure about how the logistics of these enforcements would go, but I think having something like that would give me peace of mind.
For sure. So how do you like handle dual use concerns, like when editing microbial genomes with CRISPR?
So, I don't want to be giving anyone ideas,
Okay.
because I'm thinking about it and I'm like, oh, you know what? Like, I have one, like, I have a way. But, I think you just have to make sure that it's being handled by the right people, make sure that your work is getting approved, and also make sure that the work you're doing is really for the good and not trying to do anything that could be into some murky territory.
For sure. So, what's your stance on the use of CRISPR in synthetic biology, especially when designing like novel organisms?
So I think using CRISPR for these beneficial therapies can, be a great way to make advancements in medicine and biotechnology, so that we can definitely be, learning more and trying to make the world a better place. But then again, I think that there needs to be some sort of monitoring to make sure that our designs are being used for like a beneficial for the world type thing.
Awesome. Yeah. So, are there like any unique ethical concerns when editing specifically pathogenic microbes using
Yeah.
CRISPR?
I feel like when you're studying virulence and you're looking into more virulent genes, you could possibly make a more virulent pathogen, and that can become a big deal. Either, someone could use that as a select agent, or, it could get out on accident if someone's not following proper safety protocols and stuff. So when you're handling pathogens, there's definitely more approval and more, red tape and stuff that needs to be worked through before you can actually start doing the work to make sure that that doesn't happen.
And can you go into like some of the safety protocols that are in place at the Pathogen and Microbiome Institute to avoid such situation, even though I know we don't work with such crazy stuff?
So you have to go through tons of background checks if you are entering our facility. And you it's tons of paperwork, and it's tons of just trainings and extra work, and because they really want to make sure that you know what you're getting into, and so that they know who you are if something were to happen.
Yeah, they can hold you accountable
Yes.
for anything that happens.
Absolutely.
Yeah, and I think that's some people get irked by the fact that there is so much background check in such research, but I think it's a very good way to avoid situations that could become a big problem, as you mentioned.
Yeah.
But
Because even though it's super time consuming and we think of it as like a pain, but
Yeah.
we really need it, and I think it gives everybody peace of mind knowing that we're taking care of everything.
yeah, for sure. Okay, has your lab had a conversation about biosecurity or the potential misuse of CRISPR gene editing?
I don't think we don't really even do that much CRISPR. I think we're the only lab group that even uses CRISPR. But every protocol needs to be reviewed and approved, and we have to come up with these hypothetical situations of being like, okay, if this happened, what would we do? So it's being handled properly, and I feel secure about it. But yeah, that's very important to talk about.
Yeah, absolutely. What do you think the role of the researcher is in preventing the misuse of CRISPR tools, especially when they're being more the accessibility is increasing day by day?
Yeah, absolutely. This goes back to what I was talking about when I was like, oh, this felt like a game. You need to understand the gravity of the situation.
Yeah, for sure.
You need to make sure that you're doing your work correctly, carefully, you're thinking critically, you're being a professional scientist, because these tools are becoming increasingly accessible, like you said. So we need to make sure we're not making any dumb mistakes, because this stuff is expensive, and these errors can have bad effects like off-target effects and everything else. So we really have to make sure that we're not misusing or even just making mistakes.
For sure. You kind of mentioned like also like the fact that CRISPR is a very expensive tool, and kind of tying it back to like the current like scientific situation in the world with like the limited funding we're receiving and all the like public funding cuts. Do you think it's really important to like? Do you think somehow like making the ethical issues more seen and like more talked about inside the community that uses this technology is also important because of the funding cuts?
Yeah, I think it just with these cuts and just the threat of losing our progress and everything, I think it's like very important that we're still able to, we want to have the public on our side because we want to keep working, and then we need to also treat everything in the lab and, on the computer, like what I was doing, very carefully, because now this stuff has become precious. If it's super expensive and, we might not, be able to have the opportunity to buy more,
Yeah.
given a current situation, and it's very scary. And I think, something needs to be done so that we don't have to be in this type of fear anymore. We still want the public on our side anyway, but I think what's been happening across the country is really sad, and yeah, it's just a rough time.
Yeah. I'm so sorry about that. And like everything that's happening is very scary for all researchers across this country. But it kind of is also interesting, like being ethically aware and like thinking about the ethical implications of research not only like makes you do good research, but also can help you save some money.
Yeah.
Because if the more careful you are being, the less you will be wasting these
Right.
precious resources. So that's just something that I think is very interesting. So moving on to our next question, I wanted to ask you, what do you, my bad.
you're okay.
In a pharmaceutical setting, how do researchers ensure CRISPR application prioritize patient safety over profit?
This was a loaded question for me. Great question, and it's something we definitely need to be talking about, because sometimes money and corporate greed go crazy in this world, and it sucks. But I feel like in a pharmaceutical standpoint, you need to be having tons of preclinical studies and just making sure that everything's going smoothly before we start even working on people,
Yeah.
Tons of oversight, tons of regulations to make sure that what we're doing is fine, and to make sure that we're being safe with it and not just trying to cut corners. And we're trying to make sure that these off-target effects with CRISPR technology are being minimized as much as possible.
For sure. So, do you think pharmaceutical companies have too much influence over CRISPR development in the current scenario?
Honestly, like that was such a good question, because I mean, my background with CRISPR, the last thing I thought about was pharmaceuticals, strangely enough, because I'm on the biology side, so I'm always thinking about how we could use this, for biology and for infectious diseases. And because CRISPR is essentially like a bacterium's immune system. So I'm just like, okay, like this is only really going to go towards microbiology. But hearing that, pharmaceuticals want to start using it was really interesting to me, and I'm really eager to learn more about it, actually.
Yeah, for sure. It's just like I think from a scientist standpoint, it gets like a little like weird when like industry we really don't think about the industry and
Right.
like in the bigger picture of things, like, but when the topic comes up, it's always like a kind of an iffy situation because we as researchers don't really think about the profit of it.
Right.
But the whole point of the pharmaceutical industry is to kind of profit off of these technologies.
Yeah.
So kind of like the ethical, like I don't know how pharmaceutical companies work. I would love to talk
No.
to somebody from there
Yeah.
someday. But I really hope they are also being ethical in their use of CRISPR, because it is very possible that a company out of greed does something that ruins like the technology for everybody else.
Right.
Like we've seen like in previous cases of like companies using some technology to make something that that was good in the bigger picture but is now being misused.
Right.
So completely agree with you on that, that pharmaceutical companies also really do need to keep thinking about the ethical
Right.
implications of this technology.
Because they're a business, so it's like
Yeah.
we don't think about that. We're not thinking about how much money we can make from doing something. You know, we're just trying to get it done and trying to like help people.
Yeah, that's like the big difference between academic research and pharmaceutical research. But at the end of the day, it's both research. So, like, just keeping like both in check kind of is necessary. Do you think so?
Yeah, I think we absolutely need to be keeping these companies in check because, you know, they're a company, so we can't put anything past them. So we as scientists have to kind of make sure that industries are using this technology and these resources
But
correctly.
it's kind of good to know still that the companies don't have much influence over what the development of CRISPR is because
Right.
it's mainly still in the academic space
Yes.
currently.
Yeah.
And I hope even if it does migrate into like the more industry side, that it continues to be a good tool.
Right.
So kind of moving away from that, but staying on the topic of industrial uses of CRISPR, how do you feel about using CRISPR to develop antimicrobial drugs or engineering probiotics?
I love it. I'm a big fan. I think using it for beneficial microbiology is great. I think for, you know, antimicrobials and probiotics and just things that can help us people be healthier. And I think that is the good of what CRISPR can be. And I mean, I was using it to learn about an infectious disease. So if I were to be against it, then it would be kind of ironic. But yeah, that's great. I love learning more about the technologies and what we've seen and how we can help people.
Awesome, yeah. So kind of going off of that, what do you think are some risks of relying on CRISPR in drug development pipelines?
I think, you know, relying on it could be too much and can cause negative effects that I mentioned earlier, like off-target effects, unintended mutations, DNA damaging, and otherwise could just be inefficient because the process of using CRISPR actually takes longer than you think it would. It's not something we can just do right away. And we also can't really see what's going on the molecular standpoint of the CRISPR because we would have to, you know, sequence it and then, or, you know, use PCR and then see what happens. And that's how we find out if our CRISPR worked, didn't work, partially worked, because you can even get like a partial knockout. You might not cut the whole thing, which is really interesting. And that takes time and resources. So I feel like there's got to be more like efficient and effective ways to use other technologies and drug development practices. Because CRISPR, I think, is I don't think we're there yet with CRISPR, first of all. And then I think just relying on it too heavily can, you know, not be super efficient as the other stuff.
So that's another thing that I think it has been like, I'm glad that you brought it up because it feels like the public thinks, because CRISPR-Cas9 especially has been advertised as gene scissors. That's what the public refers to as. And a scissor is almost always exclusively good at cutting everything.
Right.
But CRISPR, even though it has been like being called a type of gene editing scissor, is not perfect.
Right.
You can't just use it to cut between two parts of a thing. It
Yeah.
really depends. It sounds like it really depends on how it's gonna work in the experiment, how
Right.
it's gonna react with the actual microbial cell, and how it's gonna actually do its work.
Right,
So
because you could do everything perfectly. Your designs could be unique, and you think that on screens they look effective and can do the thing, and then in the lab you could do all of your transformations perfectly, and it could grow just fine. And then when you come to look at it, it could just not work because sometimes it just doesn't do what it needs to do. And that's, I think, something that a lot of people don't realize is there's a lot of challenges in this type of research.
Also, kind of like from going off of that, I feel like in the public, CRISPR has been advertised as this perfect technology already, which has so much potential to like cut genes out, like straight up cut like genes out of people and like things and all this stuff. But do you think like maybe advertising CRISPR for what it truly is, just an enzyme that is produced by these microbes as an immune system or immune defense, would help the public realize that it's not something crazy, it's not out of a sci-fi book, it's not just a computer code that is going to cut genes and like replace them?
Yeah. It doesn't sound as cool when you put it that way. But that is what it is. And, you know, I think someone trying to sell that type of, like, sell what this enzyme does and, you know, trying to maybe make some money off of it or promote more research, they're not going to word it like that. They're going to word it as, like, the potential that it has, even though it's not perfect and probably will never be. The wording and advertising of this science is very important.
For sure. Okay, kind of wrapping up here because we're reaching time. My last question for you is, can CRISPR reduce the time it takes to develop new antibiotics or therapeutics? And if so, what are some ethical trade-offs of such practices?
So I think it has the potential to, you know, do these efficient developments, but we're not there right now. I feel like the quicker we are with it, the more risks and negative effects we can have. So we shouldn't be rushing anything. We should be, you know, taking it slow because this is very innovative technology to be using it in this type of standpoint. So I think it has some great possibilities, and I'm very excited to see what happens, but I'm also very scared because we need to be making sure that this isn't getting into the wrong hands, and we need to make sure that we're doing everything carefully and that we are going to be helping people rather than hurting them. So we should not be rushing to avoid any ethical conundrums.
Thank you so much, Nicole, for this conversation. From this conversation, we really got some really great insights into what the current actual use of CRISPR is and how it's being like tested in the scientific community. And I hope this episode will help like reduce a little bit of stigma around CRISPR, because we talked a lot about how CRISPR is not as scary as it's being presented, and it's not even close to what its actual potential is.
Right.
And hearing about all your research and all the ethical concerns you have and like things you have in place, like protocols and stuff to minimize such ethical risk or like causing like scary situations is really great. And I just wanted to thank you for coming on this podcast and talking to me today.
Yeah, of course. It was a great conversation. I'm very happy to be talking about science with people. So yeah, this was a great talk.
Okay, before we end it, Nicole, would you like to like give out your social media or something? If people want to reach out to you or connect with you,
Yeah.
you totally don't have to.
No,
but
absolutely.
If you want to.
So my Instagram is Nicole Doolin, but the I in Nicole has 2 I's instead of 1, but it is just my name. And my TikTok is, I believe, Nikki Dublin. So
Okay.
it's the opposite of what my name actually is. But that's how you'll find me.
Awesome. Thank you so much, Nicole.
Yeah.
And I hope all of you listeners had fun following this conversation, and tune in again next week for another episode of Editing Humanity.